Hello students, Ms. Slyman here. This is a really fun pattern problem, the type of application that we see on our tests and stuff. So I really encourage you to think about this one on your own for a bit before watching the video, or watch a bit and then pause maybe. And I can't remember if I fixed this typo on your document or not, but hopefully yours says given the square figure. The shading process continues indefinitely. Write an expression using sigma notation to represent the total area. Well, if we're looking at the side of the largest square as L, so this whole side is L, and what we're looking for is an expression where we add all the shaded areas. So even though I know that technically I could keep going smaller and smaller inside of here, my area is bounded inside this original square. So I want to find sigma notation for area 1 plus area 2, area 3, etc. So I want to figure out how each of those areas is calculated. Well, my first area, so let's look at this. The first area is 1/4 of the total square. The second area is 1/4 of that. So it's 1/4 of A1, so that's going to be 1/4 squared times L squared. And now area 3 is going to be 1/4 of this, so I'll have 1/4 cubed times L squared, etc. So if I want to sum all of those in sigma notation, I'm going to use K equals 1 to infinity. So I'm going to add up infinite areas of 1/4 to the K power times L squared. So there's my sigma notation. So here's my A. In B, my R value is 1/4, which is less than 1. Therefore, we can find a sum to infinity. So if I sum 1/4 of each progressive square's area, the sum to infinity is going to be the original area. So that was 1/4 L squared over 1 minus my R value. So I'll get 1/4 over 3/4 L squared, which is 1/3 L squared. So if I totaled all of these shaded areas, in the end, it would create 1/3 of the total square. Pretty cool, huh?